All right, so if we take a look at number 4, number 4 said, I have 10b to the 8th divided by 2b to the 6th. Is this the one you're talking about, sweetie? Okay. This is a note to all of you. Everyone look over here. Everyone look over here. I want you working down your page with all your math. Do you know that you have no space to do any corrections now that you've done that? Okay, can you not do that? Maybe you can like flip it over and you can do it on like the back cover. You know what I mean? Okay. I want you guys to make sure that you are working down your page. Everyone take a look at your work right now. I'm not looking for you to tell me anything, but I want you to look and see. Are you working straight across your page? Or are you working down your page? If you're working straight across the page, the problem is you have no correction space. You have no space to make any notes. How many of you guys have heard me say before, I want you working down your page? All right, not all of you are doing that. I need you working down your page. I know it looks like there's a lot of blank space, but that's okay. That's where you take notes. Okay? So, the first thing I'm going to do is I'm just going to kind of rewrite this so I can divide out common factors. All right, 2 divides into itself 1, 2 divides into 10 5 times. So I have 5 in my numerator, I have 1 in my denominator so far. All right, now I have my b's that I'm dividing. In the numerator only, this is our division power rule. In the numerator only, you are leaving one of the bases and you are subtracting the exponents. So I have b to the 8 minus 6. To simplify this, well, when I have a denominator of 1, I don't need to show that denominator of 1 anymore. So I'm going to get rid of that denominator of 1. You guys, I need to see some equal signs. This is what I'm seeing on some of your pages, and it's a lot of you that are doing this. Some of you are doing an awesome job, but there's enough of you that I need to say this. There are some of you that are doing this. And there are just things randomly on your paper. How many of you guys can see that this is going to get confusing? Particularly when you have a lot going on. I need some equal signs. I need this to be underneath it so it's easy to be like, okay, she went from here to here and then here to here. If I can't keep track of what direction you're going in with your work, I'm not giving you full credit for it. I want you to pretend that you're correcting the work. And you can see why I'm really pushing you guys to be very organized. All right, so from here, I am going to do 5 times, well, b to the 8 minus 2 is b squared. So Christiana, there is number 4 for you. Are you cool with that? Awesome. I'm sorry. So did you just get 5 on that? Okay. Unfortunately, if you're not getting your books from here and you get them online, if you don't get exactly the same edition, Romano, were you the other one that had that? If you don't have and Aaron, you are as well. If you guys don't have a book from here, you guys have an edition that you bought online, and it's a different edition that we have, it has to be exactly the same ISBN number. If it's not, there are going to be variations to it, and I don't know what to say. It's not always. It kind of happens randomly, doesn't it? Are you finding it all the time, ladies and gentlemen? Just this one. Are you finding it all the time? Are you finding it all the time? You did. Okay, so every once in a while it's going to happen, so we just kind of have to make do. Okay. All right, what else can I do for you guys? Yeah. 14? Okay? Thank you for asking questions, Christiana. So if I take a look at 14, I have negative 2 to the 4th divided by negative 2 to the 4th. All right, this bears repeating. I recognize that because if we look up here in this one, number 4 that we did, how many of you guys noticed that we divided out common factors between the 10 and the 2? Okay, why were we able to do that? Why were we able to do that? Layla? They were different numbers. I agree with that. Why else were we able to do that? Frankie? Yes. However, I want you guys to compare this. I have 10 divided by 2. I'm going to say versus 10 squared divided by 2, let's say squared. We already talked about that we can DOCF on that first one. Can I DOCF on the second one? Aaron? Yes, that's exactly right. I cannot DOCF here because there are exponents. You can't. Even though they're the same exponent. If we forward on to this one, even though these are the same exponent, even though these are the same base, you cannot divide out common factors here and be left with 1 to the 4th divided by 1 to the 4th. You cannot do that because they have exponents. So, when they have exponents, even if they are the same base, I need to use my power rule. So, in parentheses, it's negative 2 only in the numerator. Dominic, you're listening. Only in the numerator. There's nothing left in the denominator other than a 1. Because remember, using the power rule is dividing out common factors. That's why we do 4 minus 4. Because there are 4 negative 2's in the numerator, and they're canceling out with the 4 negative 2's in the denominator. Up here, I had 8 b's in my denominator. They cancel out with 6 of the b's in my numerator, and I'm left with just 2 b's in my numerator. That's what this power rule is doing. All right, so I can't divide out that negative 2 here. My negative 2 is still my base. So I end up with negative 2 in parentheses because it is the base. 4 minus 4 is 0. So I have negative 2 to the 0 power, which equals a 1. And this is all the work I should expect to see for that kind of a problem. So while you may have gotten it right, I want all of you looking at your work for number 14, please. And make sure this is the work that you are showing. If not, you're making corrections to it in your marking pen. Layla. Oh, no, it's not okay. You have to put parentheses around it because it is a negative base. If that was a positive 2, you don't need them. But since it's a negative 2, that whole negative 2 is the base. So, yeah, you need those parentheses. All right, what else can I do? You guys have awesome questions. Yes. Yes. No. Here you don't have to show negative 2 over 1. The reason I do is because there are still a couple students that are leaving a base in the denominator. And I need you guys to recognize that you don't have, when you use this power rule for this set that you're dividing, there's no longer a number in the denominator. It is a 1. You don't have to show it. All right, put this away, get your notes out. Let's talk about the last power rule for this section. right, so we are still in 4.8, so 4.8 continued. All right, today we are going to be talking about negative exponents. Today we're going to be talking about negative exponents. Yes? On the last homework? Very quickly, what do you have? So all of you write review in here, and let's take a look at this, one of the problems. So let's do an example. All right, so that is number 43. All right, so 43 said, I have 5x squared divided by 10x to the negative fifth. Okay, so here, Frankie, this is a good one that you're asking me because it has a negative exponent in it, doesn't it? Okay? Even though it has a negative exponent, I'm still using my division rules. How many of you guys recognize that? Okay. So if I use my division power rule, I'm just going to rewrite this because I don't want to cross anything out on my given. So I divide out common factors between the 5 and the 10. So far in my numerator I have a 1, in my denominator I have a 2. So Frankie, are you cool with that? Okay. Now I'm going to be doing the division power rule on x squared divided by x to the negative fifth. All right. Even though that's a negative 5 as an exponent, I'm still going to use my power rule. Okay, that doesn't change the process. So in the numerator, I'm going to do x to the 2 minus a negative 5. Well, anytime we have subtraction, what do I always recommend you do? Even if it's in these exponents, it doesn't matter. What do I recommend you do, Michaela? I recommend that you do adding the opposite. So 2 minus a negative 5 is the same thing as 2 plus a positive 5. We change the subtraction to addition, the number after to its opposite. You're all writing this down, even if you got it right in your homework. So now what we have is, we have in the numerator x to the 2 plus 5, which is x to the 7th over 2. So even though that's a negative power, we still apply the same power rules. Now if we came up with a negative exponent when we did that math, okay, you're going to understand what to do with a negative exponent today, okay? But if you did that the right way, which a lot of you did, you recognize, oh, that's just going to be x to the 7th. All right? Does that help you? Okay. So let's talk about, yes, Kira, or Layla. No, I've said that already. I don't mind if you leave the 1 in front of it. This is the same thing as 1 times x to the 7th over 2. But as I've said before, a coefficient of 1, we normally don't leave it in. Just like an exponent of 1, we don't usually leave it in. If it helps you right now to leave it in, by all means you can, but I do need you recognizing that like on the high school placement test next year, it's not going to show a 1. On the SAT or the ACT, it's not going to show a 1. In your answers in the book, it's not going to show a 1. So I do need you to recognize that you might show that 1 there, but you're good if they don't. You know what I mean? Okay. All right, so let's talk about negative powers. Okay, I'm going to use expanded form again to prove to you what the power rule is. While we're doing this, it's also going to prove to you that zero power rule again in a totally different way. All right, it's going to prove to you that that zero power rule is what it is. All right, so let's take a look at 2 squared. Let's look at 2 to the third. And math is all about patterns. It's all about patterns, which is why we're able to do these power rules. Why we're able to do, why division is repetitive subtraction, and why multiplication is repetitive addition. We're able to come up with those patterns. So we're going to look for a pattern here. Okay. 2 to the third power means 2 times 2 times 2. How many of you guys agree with that? Okay. So what I want us to do is, I want for us to subtract 1 from our exponent. All right, so I'm going to have 2 to the second power. What does 2 to the second power mean? Kira? 2 times 2. Well, to get from 2 times 2 times 2 to 2 times 2, I'm dividing out a 2. How many of you guys recognize that? So going from here to here, we kind of divided off a 2. Does that make sense to you guys? Okay. Let's do the same thing. Let's subtract off a power of 1 again. So my new exponential form is 2 to the first power. Well, again, I'm dividing off a 2 for my 2 times 2, which leaves me with just 2, which is what 2 to the first power is. It's just 2. You guys with me so far? Okay. If I subtract 1 off of 2 to the first, what is my exponent? If I subtract 1 off the exponent of 2 to the first, what's my exponent? Alex? 0. Well, what do we know x to the 0 power equals? Aaron? 1. Which makes sense, because if I divide 2 by 2, don't I get a 1? So we've just proven that 0 power rule again. We didn't need to, but we did. Let's do this again. Let's subtract negative 1 off the exponent one more time. So what is my exponent on my 2? If I have 0 minus 1. Angela? Negative 1. All right, well, let's take a look here. I'm continuing this pattern of dividing by 2 all the way down. What is 1 divided by 2 as a fraction? How do you write 1 divided by 2 as a fraction? Pierre? 1 over 2. Now, dividing by 2 is the same thing as multiplying by a half. How many of you guys know that? So dividing by 2 is the same thing as multiplying by a half. So let's do this pattern one more time. Let's subtract 1 off my exponent again. What is my exponent on my 2 now? If I have negative 1 minus 1. What's my new exponent? Kira? Negative 2. All right, well, what is 1/2 times 1/2? Remember, because we're dividing by 2 or multiplying by a half from 1 as we take one of our 2's off each time. What is 1/2 times 1/2? Layla? Pardon me? 1 over 2 to the... No, it's not 2 to the 4th. Can't I write 1/2 times 1/2 as 1 times 2 over 2? How many of you guys agree with this? Okay. How can I write that with an exponent? 1 over... Do you have a question, or are you answering my question? Pardon me? Okay, how can I write this with an exponent? No. How can I write this with an exponent? What is 2 times 2 with an exponent? 1 over 2 to the second. How many of you guys are good with that? So I could keep going, but this pattern's going to be the same. So I'm telling you, 2 to the negative second is the same thing as 1 over 2 to the second. So if I had 2 to the negative third, how do you think that's going to look with a positive exponent? If you notice, I have 2 to the negative second in my numerator. To make that power positive, it's 1 over 2 to the positive 2 to the positive second power. So how can I make my power positive with 2 to the negative third? Do the same thing that you did with these two. 2 to the negative first power is 1 over 2 to the positive first power. 2 to the negative second power is the same thing as 1 over 2 to the positive second power. What would 2 to the negative third power be? Well, what's my pattern? 2 to the negative first is equal to 1 over 2 to the positive first. 2 to the negative second is equal to 1 over 2 to the positive second. If you follow this pattern of these two, what would 2 to the negative third be? Romano? 1 over 2 to the positive 3. How many of you guys see the pattern? That is my negative power rule. Okay, so let's write that power rule down and let's use it. Okay, so this is I think this is our 5th power rule. So here's rule 5. All right, this is my negative power rule. All right, so I'm just going to show you what the rule looks like and then make some notes on that. So if I have a to the negative m power, I must change negative powers to positive powers to apply the exponent, the power, and to be simplified. I have to. So I need to change them into positive powers. So if I have a to the negative m power, and this is in my numerator, to turn it into a positive power, I put it into the denominator and make the m positive. So the negative power was in the numerator here with its base. To make it positive, I put it into the denominator. What do you think I'm going to do if I have a to the negative p power in the denominator? How do you suppose I make it positive? So here, my a to the negative m was in the numerator. To make it positive, I put it into the denominator and made the power positive. What happens if my negative power is in my denominator? Where do you suppose I'm going to put it to make it positive? Pierre? In the numerator. That's going to be a to the positive p power over 1. This is our power rule. It's hard for me to put that into words. You just have to see it with a picture. So let's practice a couple of these, okay? So a to the negative m in the numerator, to make it positive, you put it into the denominator and make the power positive. If it's in the denominator, you put it into the numerator to make the power positive. And it's a positive and negative power, not base. All right, so let's look at these examples. I want you to simplify. So if I have 5 to the 6th power divided by 5 to the 8th power, I'm still using my division power rule because I'm dividing two numbers with the same base. So I'm going to do 5 to the 6 minus 8 in my numerator only. And it's always your numerator exponent minus your denominator exponent. All right, I'm going to go ahead and do adding the opposite here. When I do this, when I do this math, what is my power on my 5? I have 5 to the 6 plus a negative 8. What is 6 plus a negative 8? Come on, you guys. What is 6 plus a negative 8? Dominic? 6, a positive 6 plus a negative 8. Angela? Negative 2. So this is 5 to the negative 2nd power. All right? I'm going to put a little note here. Must turn power positive to apply the power and simplify. So if I have 5 to the negative power in my numerator, how do I turn that power positive? I 5 to the negative 2 in the numerator. Where do I need to put that 5 to the 2nd power to make it a positive 2nd power? Aaron? Put it in the denominator. So now I have 1 over 5 to the 2nd power. Now I can apply the power. So that's 1 over 25. All right, I'm going to give you another one that I want us to do as your guide that has a little bit more to it, so you have more than just this simple one, okay? Who needs to see what's up there? Okay, so let's do another one, and this will be our last one. So let's take a look at 3y to the 8th divided by 9y to the 12th. Okay, so these are separate. I have 3 times y to the 8th over 9 times y to the 12th. I like separating them so you can see that you have to handle them each separately. 3 divides into itself once, 3 divides into 9 3 times. So I currently have 1 in my numerator and 3 in my denominator. Now I have to do my y's. I'm using my division power rule. So someone tell me, I have y in my numerator. What am I doing with the exponents? Layla, tell me what it's going to look like. Excellent. So what does that mean that I have? 1 in the numerator times y to the positive or negative? Negative fourth over 3. Questions on that so far? All right. I must change that power positive to have this be simplified. So must change power to positive to be simplified. What is the only term in there that has a negative power? What is the only term in there that has a negative power? Michaela? The y. So the 3 remains where it is because it has a positive power of 1. So it's just the y. So where do I need to put my y term to make that power positive? Kira? In the denominator. So my 1 remains in my numerator, my 3 to the first remains in my denominator, and now I have y to the positive 4th power in my denominator. Kind of? You guys pretty cool with this? Okay, you guys can go.